Hi, my name is Manish Gupta, and in this video, I'm going to talk about this interesting new paper on textbooks are all you need. So let's get started. Let's start by asking this question: how has been the progress in large language models for code? In the past 2 years, several large language models have been proposed for handling code-related tasks. For example, given a documentation string or some comments, sort of generate code automatically. It sort of started with the Codex models in July 2021, and then there came in Palm Coder from Google. OpenAI also came up with more models like GPT 3.5 and GPT 4, which have not been specifically trained for code but have very good code-related capabilities. There came in Star Coder model, which is recently, then Code T5 models plus T5 plus models, Wizard Coder, and then the model that I'm going to talk about in this paper, which is in this video, which is basically Phi-1 model. Right? So as you see, the model sizes have been increasing over time. So it's the Codex 300 million was of course a 300 million sized model, but then Wizard Coder is a 16 billion sized model. Dataset sizes which have been used so as to pre-train or even fine-tune these models have also been very large, right? Like the Wizard Coder actually uses 1 trillion tokens, dataset size of 1 trillion tokens. Now, of course, with progress in time, the accuracy on these benchmark datasets, HumanEval and MBPP, MBPP stands for the mostly basic Python programs, has also increased over time. The best results, in fact, have been obtained using Wizard Coder 57.3 pass at one metric. If you give the model one chance, and what is the probability that what is the accuracy with which the model passes or comes up with the correct code, is 57.3. GPT-4 model has been able to achieve 67%. So those are some of the high numbers which are available. Right? On the other hand, for the MBPP task, MBPP dataset, essentially, again, there have been good progress. Around 52.7 is more or less like the best result in for that model, best evaluated result for that model. Right? Now, the Phi-1 model that we will discuss in this paper essentially is sort of close to these best results. So 52.7, 55. So in fact, for MBPP dataset, it is actually one of the best models. For HumanEval, it is not as good as GPT-4 for sure. However, if you look at the model size, it's just 1.3 billion, right? Very small sized model, very, very small sized model. The closest model that you see about around 1.3 billion is this 2.7 billion model. But then it has a very poor performance in terms of HumanEval or HumanEval compared to the performance that you get with the Phi-1 model. Also, the training is super cheap. It has been done using just 7 billion tokens. So the training data is actually very, very small. And all this is possible because of very high quality data that has been used to train this particular Phi-1 model. So this leads me to this question: how important is training with high quality data? So I think an important follow-up question or a reason why this question is important is the following. How to make accuracy of tasks on LLMs better? How to make LLMs, large language models, even more accurate on various kinds of tasks? So people have experimented with various kinds of methods. The most popular ones being increasing the model size or training longer with more compute. So of course, what has also become popular these days is prompt engineering. So you can do chain of thought prompting, few shot prompting, self-consistency, and so on, so as to actually get better and better accuracy. Yet another way of improving accuracy is improving the quality of the data which is used to pre-train and fine-tune these large language models. So for code, standard code datasets include the stack and Stack Overflow and code context. So these are large datasets and they also have very diverse code bases. Right? Now, the drawbacks of these standard code datasets are as follows. They're not self-contained. Many of the files inside these code datasets, many of the samples are not self-contained, meaning many of them sort of depend on modules which are external to the snippet, and therefore it is very difficult to incorporate that additional context when you're training a large language model on these samples. Many of the samples in these standard code datasets do not involve any meaningful computation. They consist of, basically, I mean that they consist of trivial boilerplate code, such as defining constants, setting parameters, configuring GUI elements, and so on. Oftentimes they include complex or poorly documented functions when those functions capture deep algorithms, right? So making them difficult to follow or learn from them. they're also skewed towards certain topics or use cases, resulting in an unbalanced distribution of coding concepts and skills across the entire dataset. But if you were to have a kid learn how to code, you would rather want something which looks like a textbook, which should be clear, concise, self-contained, instructive, and balanced. Right? If you have that kind of a textbook, the kid learns well. The models can also be expected to train well if you train on such textbook kind of data. Uh, which is what is observed in this paper while training the Phi-1 model. The Phi-1 model is a 1.3 billion parameter model. The Phi-1 base model specifically has been trained on CodeTextbook, and it achieves 29% on HumanEval performance. So, the results are shown in more detail in this chart, where there are three different models being compared. 350 million model, which has been trained for 26 billion tokens, 350 million model trained for 76 billion tokens, and 1.3 million model trained for 51 billion tokens. In this paper, there are three models which are specifically named. So for example, this one is called Phi-1 small, this one Phi-1 base, and this one is Phi-1. So Phi-1 small is a 350 million parameter model, but it has been trained using 76 billion tokens. Phi-1 base is a pre-trained model, in some ways, a 1.3 billion pre-trained model. And the nice part is that it can actually achieve around 27% pass at one accuracy on HumanEval. Yeah. Now, so an interesting point to sort of note is that if you train on standard data sets like the Stack, Stack Overflow, and so on, you can only achieve so much of pass at one accuracy across different model sizes and model compute power, right? However, if you basically start training on on CodeTextbook and code exercises, which are cleaned versions of code data sets, you actually suddenly see that the accuracy improves across all different model sizes. So for example, if you basically not just pre-train on the CodeTextbook data, but also further fine-tune on the code exercise data, you observe that the Phi-1 model actually has a very high performance of 51%. Okay, so that's that. Now, how is Phi-1 trained? How is the Phi-1 model trained? Phi-1 model is a LLM for code. It is a transformer decoder trained with flash attention. It is trained using deep speed on 8 800 GPUs. 1.3 billion parameter Phi-1 model actually contains 24 layers and 32 attention heads. The smaller model, which is 350 million, Phi-1 small model, it contains 20 layers and 16 attention heads. They use rotary position embedding. Now a little bit about the Phi-1 base and the Phi-1 model. Well, Phi-1 base and Phi-1 model, both of them are 1.3 billion parameter models. Phi-1 base is a pre-trained model. It is pre-trained, from scratch, transformer decoder model, and it has been pre-trained using a dataset called as CodeTextbook dataset. In the next few slides, I'll talk about how this CodeTextbook dataset is created. Okay, it has been trained for 4 days on 8 800s. That's a very small amount of compute power if you think about it, right? Just 8 800 machine is what you need with 4 days of that, and you can actually train a Phi-1 base model. It does 8 passes over this CodeTextbook dataset, which consists of these two parts. The first part is 6 billion token dataset, which has been obtained by filtering code language corpus and synthetic textbooks. The second one is a completely synthetic textbook dataset, which consists of less than 1 billion tokens. So overall, 7 billion tokens in this dataset. So the synthetic data set has been obtained using GPT 3.5. GPT 3.5 was used to generate Python textbooks, as we'll see soon in the next few slides. Okay, so that's the pre-training part. This is the pre-training part using which Phi-1 base model has been pre-trained. Now the second part is the fine-tuning part, which is how the Phi-1 model has been trained using the Phi-1 base model. It basically just requires 7 hours of fine tuning. That's it, on the same 8 800 machines with code exercise data. Now, code exercise data is again a very small data. It contains 180 million tokens of synthetically generated textbooks and exercises, again using GPT 3.5. We will quickly talk about how the code textbook data is obtained, how code exercises data is obtained, and also how this filtering of the code language corpus is done in the next few slides. So how was high quality data obtained for training Phi-1 models? Well, the first step is to filter existing code data sets. The authors actually started with Python subset of the deduplicated version of the Stack and Stack Overflow. So that's the original base data. these billions of such files were actually or billions of these tokens in these files were annotated for quality using GPT-4. Not all of them, just a 100K subset of these large number of files were annotated using GPT-4 for quality. Given a code snippet, GPT-4 was basically prompted to determine its educational value for a student whose goal is to learn basic coding concepts. So for example, this particular first part of the code basically would be labeled as high educational value because, well, it basically tells you how to perform L2 norm, how to compute Euclidean distance with appropriate comments and so on. While this is going to be called as low educational value, because if you see, it sort of looks like more like templatized code, boilerplate code, which basically is just doing self-taught. So setting some properties, that's it, rather than actually teaching how certain functionality can be used, let's say in a torch, like in the torch library. Okay. So using this small 100K subset of labeled data from GPT-4, the authors actually trained a random forest classifier that predicts the quality of a file or a sample using the output embedding from a pre-trained code gen model. Okay. That is the first part of obtaining the code textbook data. The second part of code textbook data is actually obtained synthetically using GPT 3.5. So the idea was to ensure that the examples generated by GPT 3.5 should be diverse and non-repetitive. Now, by diversity, we basically mean that it should be diverse in terms of coding concepts, skills, and scenarios. It should also be diverse in terms of level of difficulty of problems and examples, and also complexity and style of the examples. However, achieving diversity using GPT 3.5 or for that matter, any LLM is non-trivial. LLMs typically tend to repeat the same concepts and solutions over and over again with minor changes if there are only small little changes that you do in the prompt. So how to basically obtain diverse examples from LLMs is complex. So the way code textbook data has been obtained, well, it's a high quality source of natural language heavy text interleaved with relevant code snippet. So there is text part, which describes what is going on, and then there's an example, and then there is also code part. So there is interleaving of text and code. And well, diversity is obtained here by providing constraints on topics on which the text and the code should be written and the target audience of the generated textbook. So that's that. Now, the third part, or rather the fine-tuning dataset for Phi-1 model is the code exercise dataset. This dataset consists of Python exercises and solutions. Each exercise is basically a docstring of a function that needs to be completed. In fact, the GPT 3.5 model was prompted to perform function completion based on the natural language instruction that was passed as part of the docstring. Right? The data has been generated using GPT 3.5, where the main means of eliciting diversity is by considering the function names. So you basically give various function names and then give the docstring, and you expect that the GPT 3.5 model will output interesting pieces of code, so diverse pieces of code. Okay, so we have talked about how Phi-1 model has been trained, and also we talked about how the high quality data for training Phi-1 model has been obtained. Now, how does Phi-1 model perform on a variety of code-related tasks? Right? So interestingly, it is observed that Phi-1 exhibits a substantial improvement in executing tasks that are not featured in the fine-tuning dataset itself. For example, fine-tuning improves the model's ability to use external libraries like Pygame and Kinter and many other libraries. Okay. For example, if you look at this prompt, Alice, Bob, and Charles are playing games. Alice first picks a random number from 333 to 678. Bob then picks a number starting from Alice's number to 888. Charles then picks a number starting from 123 to Bob's number, and so on and so forth. So as you observe, the Phi-1 model actually very nicely generates code which is perfectly suitable, perfectly correct code. On the other hand, if you look at Phi-1 base model or Phi-1 small model, well, Phi-1 base model basically just is stuck in terms of defining some variables. While Phi-1 small model does try to generate some reasonable kind of code. However, it also cannot generate very good code. It doesn't end up generating correct code anyway. Phi-1 also has a better chat capability than Phi-1 base model, despite that the chat data is sort of exclusively used in pre-training part and not really in the fine-tuning phase at all. While Phi-1 base, of course, is the pre-trained version. Phi-1 is the fine-tuned version. So here's an example. Prompt is basically a student saying, I have a Python pyplot. I want to increase its resolution and rotate it. What should I do? So, and then the prompting is done as a TA. So, expect the model to act as like a teaching assistant and answer. And the model sort of generates a very awesome output, first telling in terms of text what should be done, and then also giving an example in terms of code that this is how it is done. Okay. So what are the limitations of Phi-1 model? Remember, Phi-1 model is very small. So compared to very large models like StarCoder or various models that I mentioned in the beginning of this slideshow, like Wizard Coder and so on, Phi-1 model is just 1.3 billion parameters compared to 10x plus parameters. And it has also been trained on just 7 billion tokens compared to 52 billion tokens or even 1 trillion number of tokens that have been used for training other kinds of larger models, right? So given that, there are some limitations in the Phi-1 model. For example, it is very sensitive to prompt variations. Performance drops significantly as the length of the prompt increases. For example, if you give a prompt so as to generate a neural network with 3 layers, it does okay. You basically tell it to sort of also add a 4th layer, and well, it just basically cannot perform that well. Phi-1 fails when we increase the number of layers from 3 to 4 in that senses. Okay. And you see another example. I'll talk also about this other example. The idea here is that even though the network sort of the Phi-1 model sort of fails in terms of generating a network with 4 layers, but then you just include in the prompt this small little line import torch, and everything somehow seems to work perfectly fine, thereby saying that the model is pretty sensitive to prompt variations. The generation may actually appear qualitatively different with a slightly modified prompt. Okay. The model is also sensitive to natural language inputs. Phi-1 sort of demonstrates less robustness in handling natural language compared to ChatGPT or StarCoder kind of models. For example, here is a prompt example. You say, Alice is moving a point along XY axis at every iteration. Every time Alice moves the point randomly with one of the options, one of these 3 options, right? So this is good. The code is good. We are trying to choose one of 3 options. And the first option says X increased by 2, Y decreased by 5, increased by 2, Y decreased by 5. Second option says X increased by 1, Y decreased by 2, X increased by 1, Y decreased by 2. That's okay. X stays unchanged, and the model somehow cannot understand this. So it basically says X equal to 0. Now X equal to 0 doesn't mean X stays unchanged. But then if you just change the wording a little, X stays at X, it basically just performs perfectly fine. Now, of course, Phi-1 model has not been instruction fine-tuned in that senses, and therefore basically, it does not really understand X stays unchanged that well. Okay. Phi-1 model is also bad at counting and spatial reasoning. So essentially, for example, if you basically create a application, you want 2 text fields, but then Phi-1 model ends up basically adding 3 different text fields, and you basically say 3 buttons at the bottom. It misplaces the button in the scene, right? When it creates the code in this application. Okay, so to summarize, Phi-1 is an LLM for code. It is basically a 1.3 billion model with 24 layers. It's a transformer-based decoder trained with flash attention. It's pre-trained with the cleaned and synthetically generated CodeTextbook dataset, fine-tuned with synthetically generated textbooks and exercises. The synthetic dataset has been generated using GPT 3.5, where diversity has been elicited by giving different topics and a different audience as part of the prompt. Phi-1 outperforms several competing models on HumanEval and MBPP, mostly basic Python programs datasets, despite being 10x smaller in model size and 100x smaller in dataset size, which is used for pre-training or fine-tuning. It this entire exercise sort of demonstrated that high-quality data improves the learning efficiency of large language models, specifically for code in this particular case, as they provide clear, self-contained, instructive, and balanced examples of coding concepts and skills that the model can learn from. Okay, hope you liked the video. Thank you for watching. Connect with me on my LinkedIn or watch my research on my homepage. Thank you.